Hello and welcome to the open source Silicon stream. And I think we are on number 12 now. Yeah, last week we were missing because we had a very big power cut in Spain. And I was worried that that wasn't going to work out, although my building has UPS and I actually had internet and power all day long, just not overhead lights. By the way, if you're watching on YouTube, can you let me know if the audio is fine and tell me where you're tuning in from? So, as usual, we're going to start off with a little bit of news, and then we've got Pat Deegan joining us to give us the next SpaceX Capsule 2, talking about project updates and how you can submit your designs to run in low Earth orbit, testing tiny tape out 6 designs. And then we've got Sabine Bleeptrack joining later to talk about silicon artwork. And that's going to be really cool. We're looking at not only like creating art by running interesting designs on the chip, but also putting art itself on the chip. So stay tuned for that. And let's kick off with the news then. So a couple of things happened recently in the open source silicon space. One is that we've got a couple of new multi-project wafer services starting up. So we've got Chip Foundry and Wafer Space. So let me just present my screen here. Share screen. So Chip Foundry is a new project that's coming from Jeff and Mohammed, who were the originators of eFabless. So it's very similar to eFabless offering. There's an FAQ here. You can have a look at how does Chip Create differ from Chip Ignite. And they've got a schedule where they're planning their first tape out in September the 16th. And it's on Skywater, and it's going to be very, very similar to Chip Ignite. So the same pad frame, everybody gets the same area. 100 QFNs. Is more expensive. It's $15,000 now. And I think they've got a sign up. If you want to stay updated, you should sign up there. And we're due to have a chat with them in the next weeks to see if we can get a similar kind of deal that we had beforehand with eFabless to be able to continue manufacturing on Sky 130. So that's looking good, and that's a great opportunity to have. Just say thanks to Pranam tuning in from India, and James, thanks for the feedback on the sound, tuning in from the Netherlands. And then we've also got Wafer Space, which is doesn't yet have any schedule. Still, things are ongoing. It's a project from Tim Ansell, who many of you will know was one of the main figures right at the beginning, getting the investment from Google to do the open sourcing and getting the Sky 130 PDK opened up, and did the big announcement on the FOSSI dial-up during the pandemic. And he's set up this new company called Wafer Space. It's set up in Singapore. I've been asked to be one of the advisors. So there's a bit of information here. Tim, there's me, Tom Spyru from Open Road, and Zobs, Bunny Huang, Boris Merman. So he's got some cream of the crop advisors. And it's quite an interesting offering that he's working on. I mean, this is like, there's no set price, there's no schedule yet, so it's still a work in progress. But it looks like very interesting numbers. $8,000 for up to 500 raw dies would be pretty amazing. You're typically looking at, I don't know, 10 to 15,000 for NREs on a packaging setup. But then once you've done that packaging setup once, it can be pretty cheap to reproduce. But you'd still be having to do some chip on board wire bonding or wafer probing or some kind of packaging with these chips. So it's still very interesting and good to have some options coming up. And that's all I'm going to say about that. Andy's saying, that's exciting, potential option to rerun Tiny Tape at 8, 9, and 10. Certainly, Andy, that's an option to rerun on the Chip Foundry offering, because we basically got the same space on the reticle with the same process and the same PDK with the same foundry. So it would be very easy for us to either take Tiny Tape 8 and 9 and just manufacture them again, or take 8, 9, and 10, squash them into one chip, and then get a new chip made with all of the analog designs, which would be great for us to be able to satisfy all the people that submitted analog designs. The wafer space one would be harder for us, and we're still a long way away from being able to run Tiny Tape out on Global Foundries GF180. We are pursuing some kind of sponsorship, industrial sponsorship, to help us pay for the engineering costs to do that. But once that's done, this looks like a potentially great way to get things manufactured. So yeah, keep your questions and comments coming in. And another bit of news is, you've probably seen this already, but the timer, the countdown is back up again on our next tape out with IHP 25B. I think we've only got one project being submitted from Timothy Edwards, an e-ink driver. So that's pretty cool, having our first submission in there. Plenty of time on that. And just a reminder that this IHP shuttle does have the loan forms that you've got to, let me see if I can find that, loan terms. So you have to agree to these loan terms due to the way that the silicon is funded. And one thing that has been misunderstood and probably not well enough communicated and then picked up on and re-reported with mistakes in it is it's only this one and the next IHP shuttle that will have this loan terms. After those two are finished, we'll be paying for the silicon and we'll be able to do what we want with the chip. So there won't be any loan terms. There won't be any export restrictions. So it's just these first two chips. The silicon's being paid for by a German taxpayer money. So that's where those restrictions come from. Okay, so a couple of news on the SpASICs stuff before we get Pat on. So Pat did a cool interview, not an interview, a psychogenic tech video about his work on the SpASICs project. So that's well worth a watch, and I'll drop a link to that in the comments over here. And Pat and I also interviewed Tibor, who's our contact at the university, which you can see here. And we talked about a bunch of stuff like their previous missions, where our project is going to go, how it deploys the solar panels, how it moves itself in orbit with these cool magnetorquers and stuff. And then Pat did a little bit of a show and tell about his work on the PCB design layout and stuff like that. So that's also worth watching if you want to know all the information about SpASICs. And that's a good time to transition now to get Pat on. How's it going, Pat?
Oh, pretty good. How are you? It's good news on the MPW stuff. I'm excited about all that.
Yes. That's I mean, we're still a long way away from being able to order silicon, but it looks like
Coming along.
by 2026 we might even have access to 3 different technologies, which would be
be nuts.
Yeah, that'd be great.
So yes, SpaceX. A couple of things have been going on. I am hoping to actually ship in a box tomorrow if all things go well. So that's good. So to the internal team, but also to Tibor. And so it wouldn't be the final version of the firmware and all that and all the tests, but at least the hardware would be in place, and we have a mechanism to update that.
Great. So you succeeded with your getting it right on the first try, then.
It seems that way.
Where's my do button? I'm sure there's I'm sure there's sound effects on StreamYard, but I've never used them, so I just have to.
We need that horn you had in the workshops there. So that's good news. Otherwise, I've been getting some help from people in the Discord. Troy Byrne has been, he actually was game enough to go deep into the weeds and start playing with the, because there was some definite trouble getting the I2C slave stuff working up and bubbling that up to the Python layer so I ended up writing a MicroPython module, and it's been kind of a pain. So he's helping up on that. We even have one submission for the SpaceX experiment that's not ours, that's from Florian. Which is pretty cool. So that's the first external submission we've got there. And actually, maybe I can share my screen and show you how that works, because right now, the focus, I mean, I'm doing my stuff and everything, but it would be really cool if other people could, write some code that's going to work up there in space.
Yeah.
And
the reason I wanted you on today was just to give us the 10-minute instruction on how to submit your design how to submit your test codes so that we can run it.
So if you've got a design on Tiny Tape Out 6 or just want to play with someone else's, feel free. It's not too hard. I'm just going to try and present my screen. I hope it'll come out nicely. Yes.
I know what I'm watching for this time.
Yeah, entire screen. Here we go. Okay, share. Tell me. I have to choose it. Do you see us? Yes, I guess you do. Okay, so in short, so there's the SpaceX distribution and all that stuff that's on GitHub, but there's a new repository which is SpaceX experiment testing. This guy here. So, whoops. If you go to the main page, which is here. Damn, why is this so hard? I've got documentation describing all of this here, so you're not going to be stuck on your own. But the short version is, without having 2 boards and an I2C thing and doing all the tough setup stuff, you can just take your Tiny Tape Out 6 demo board and run this to actually verify that you've got a test running. So the instructions are basically fork this repo, then do your stuff under SpaceX.experiment here, and then you can try it live. So let's see what that looks like here. Right now, I'm on just a Tiny Tape Out 6 demo board, one without actually an ASIC, but it doesn't really matter. So what I'm doing is creating one of these experiment runner objects here, and then what I can do is I've set it up so that experiment 2 is Florian's actually. So I'm just going to launch it. And then while it's running, so that launches it exactly like the SpaceX module will do. And then I can just keep looking at it. So what it's doing is whatever it's doing, and it just reports various values as it's going along. And I'm grabbing these, and it'll just keep this monitor until completed. Will just run until the thing says, yes, I'm done. Thank you. And so it only takes about, there we go. So what are these bytes? Well, these bytes are the result, and you get a whole 10 bytes to report whatever it is you want. Ooh, but as you can see, you can report 10 whole bytes. However, you can do intermediate reports. So if you're running, you can kind of say, okay, here's the data right now, and we can fetch that once in a while and get some updates, in the meantime. So if you have a long running thing, we can see stuff in the middle rather than just at the end. So what these bytes represent are completely up to you. In his in Florian's here, his experiment is this guy. And so each experiment has two parts to it. One's just a little loader, and that's explained in the documentation, but in essence, it's just a way to import the module inside of this and then launch it. And then the code itself is whatever you want. And so the point is you have access to the tiny tape out SDK in Python here. So here he's enabling his project and then clocking it and doing whatever he wants. And as you go along, you can set the result to whatever it is that you want. So that's pretty much the whole story. Everything is described on the in the documentation here. So yeah, the 4 instructions are basic, but you can see how to run experiments. So you have all these methods that are basically acting as the satellite would, you know, checking the results or stuff like that. But you can just run this locally on your tiny tape out demo board, and your tests themselves, well, it's all described here. You create a test module, you do whatever you want with the SDK, and then and set the results as you go along. Keep an eye on this keep running thing, because we might want to interrupt you, and that's pretty much it. Yeah, so it's all described there, and there isn't that much more to say about that. I don't know, however, if there are any questions from you or anyone online.
So there's no questions from me. What I'm going to do, so I've got on Uri's oscillating bones silicon sculpture, which is a ring oscillator. I've managed to write a bit of Python, mostly copied from somebody else's repo that can do frequency measurement, so I can capture the oscillation frequency, which is about, I think, 40 megahertz or something. It's got like a different tap, so you can get like faster and slower taps. And then I'll just capture that while the test is running and kind of average them every 5 minutes and create a report. So then hopefully we can use that as a way to monitor the speed of the ring oscillator as it moves in and out of the sunlight, which should make it go faster and slower. So I will attempt to add that to the repo, and I'm very pleased to have been beaten to it by Florian. Good job, Florian.
Yeah.
And yeah, if I get stuck, I'll ask on the SpaceX channel in the Discord. And if anyone's watching and wants to be involved and you want to know how to get help, then join the Discord channel here. We've got a channel there called SpASICs, where people are hanging out who are involved and working on their own submissions. So yeah, thanks so much, Pat. Thanks for your hard work on this. And
and Doc's Motion Studio says that it was straightforward, so that's good. That's a good sign. So I'm really glad to hear that. But if anyone has any problems or if something is not clear, just let me know. I'm really keeping an eye on the SpaceX channel more than anything else these days. Run
your code in space, and Florian's using his floating point unit to calculate pi in space, so we can then use that in the orientation and keep the satellite on track.
Excellent. I'm helping. Nice.
Great. Okay, thanks for joining today, Pat. And
cool.
See you around. See you in the Discord.
Thanks.
Bye. All right. So next up, we've got Bleeptrack. How's it going, Bleeptrack?
Hey everyone. Great. Thanks for having me today.
Yeah. Let me just get rid of this Discord banner here. So I think at least a couple of people watching already know you, because James said that he was looking forward to seeing you. But for people who don't know you, tell us a little bit about the kind of artwork that you do.
Yeah, so my artist name is Bleeptrack. I come from a computer science background. I'm still doing my PhD in some computational creativity and arts stuff, and hope to finish soonish. And yeah, I do a lot of stuff that is in the field of generative art. So I mix technology and art. I code art pieces, basically, you could say. And what I find really interesting is to have a form of generative process included in some way. So I can hit run on my code. It uses maybe some data or a bit of randomness, and then I can create, I don't know, thousands of interesting images.
You did one recently that I really liked, which was like an NFC sticker that you could tap and you get a
sticker one.
new,
Oh, I
piece
have
of art.
one. I have one next to me. It's these ones. Not
Yeah.
sure how well they will pop out in a camera. Like
Yeah,
this.
that's good. Yeah, so they're all unique.
Exactly, they are all unique, and each one has a little NFC sticker tag inside, so you can scan it with your phone. And I use the ID and the included counter in the chip to create new, little, very geometric generative images. So the ID defines the colors, for example, and the counter gives a bit of random, it's a randomness seed basically. So for each scan, you get a new image.
Cool, yeah. And if you want to stay in up to date with Bleeptrack's cool art and get things like stickers, then you can sign up to her Patreon. Maybe we can drop a link to that in the comments.
Oh yeah, I can.
So we started talking because there's like this long history of silicon doodles that I'm sure people have seen before, where people put little graphics on the chips. Actually, I'm going to just show a few because they are cool.
They are really cool.
Silicon doodles. Let me see. Share screen. There we go. So little pictures like this. Oh, look, here we've got some even of the ones on the open source chips. Those are on all of our chips because they're part of the eFabulous Caravelle stuff. Little trains. Where's Wally? Some dog selling some watches from the inside of his coat. Yeah, but I from what I can tell, actually, there was the pulp. We've got this Google document, don't we? Let me see if I can find that quickly.
Yeah, also there's this awesome library you showed me with the silicon doodles.
Yeah. Pulp platform. They do some really good stuff that is visible from the top of the chip. Some really cool projects. So Pulp has done it, but I really feel like the medium hasn't really been explored by an actual artist. So I really wanted to work with an artist to explore doing art on silicon, and so we started talking. And maybe you can tell us where you got up to and your thoughts so far on that project.
Yeah, I'm kind of really honored to be on, because I think it's a really unique chance. It's a medium that is so hard to get your hands on. It's always, at least for me, it always feels very out of scope to be ever able to produce your own chip in one way or the other. So Tiny Tapeout, I think, is a crazy, amazing project. And so I'm currently looking at it from two angles. So there's the very cool VGA playground that we, I think, gonna see a bit later on, where you can code VGA signals and have basically your own, I'm not sure if this is the correct description, but you can code your own shader baked into a chip, basically. Very cool. And then, this also the silicon doodles. And what I'm currently exploring is I'm writing a little generator that creates the top layer of the silicon chip with a dithering pattern like you showed, basically. And what I currently find very interesting is exploring some sort of textures or some sort of weaving textures. I have a bit of code ready, but it's not nice to look at currently. So, but I think it will be very exciting to see the final decapping images. This is what I think makes it also kind of hard to do, because when I usually work, I have very short iterations and I do very prototypey stuff. So I have an idea, I try it out, and maybe I need to 3D print it, or maybe I need to laser cut it, but that's like very quickly done in the end. And then I can see it iterate. But with doing silicon doodles, it's hard to iterate at all, because the time is so long and you don't want to waste time and space to make something that's maybe not gonna look cool. So this is really quite challenging for me, I'd say.
Yeah, I think it's kind of another thing that's interesting for me is the lithography process that is used in chip manufacture. In a way, you could argue that came from like the roots of art, because it was like that being able to reproduce things with that photographic exposure methodology and etching and halftone and the printing press and all this kind of stuff is being used over and over again. It's just like the stuff we use for chips is being able to create structures that are correct to the nanometer, which isn't normally required, I guess, for like art in general. Have you thought about doing stuff?
Right. Yeah, I think.
Go on.
I just want to say, I think crafts and art are very fundamental to modern technology, right? It's like the overall technique is influential, and it's just taken a step further. Also looking at like I stumbled upon this, I think, a few months ago, like the woven memory cores that were on the Apollo spaceships, for example, are also very, very crafty and handmade pieces of technology in the end.
And another thing that I'd be interested in seeing is, because we can create structures that are similar in size to the wavelength of light, that's why you get all the beautiful rainbow and diffraction patterns happening when you look at chips. So maybe there's ways of writing scripts that create the structures so that when light shines on them or bounces off them, you like see some hologram, or you see some kind of colors that are different depending on, maybe if you have a set of diffraction gratings at one width and then like a word with lines of a different width, when you shine a light on it, the word looks blue but the background looks green or something. I don't know. I think there could be some interesting stuff to explore there.
Absolutely.
What does Pat say? If the point is art rather than mitigating weird effects like diffraction, maybe because try stuff to increase and play with them. Yeah.
Absolutely.
So there's that side of stuff, which we're off to a rocky start, because you were going to put some stuff on the Skywater chips, but then the one that you were going to go on got cancelled, and then the IHP one was kind of so experimental that we weren't able to put basically arbitrary GDS on there, because we didn't have the power gates ready for doing like full. If you're going to do like really experimental stuff, you want to make sure that it's not going to short circuit the chip. If it's like there's some kind of short circuit, we need a power switch. But hopefully for the next one, the one that is open now, that we've got like 120 days for, you'll have something ready to put on that. And then TechSplained is our imaging partner, so they're going to do the decapping and the imaging. It might be worth just also sharing my screen again and looking at the. So if we look at Tiny Tapeout 6, we've got the interactive viewer, and they were able to get rid of metal 5, which is where the power distribution is. So you can actually see down onto metal 4, which is the art layer, and you can see Uri's oscillating bones there. I think there is, and you do see some kind of some colors here, don't you, on the diffraction?
Yeah, even better on the more writer pattern you had your cursor on, I think. Yeah, this one.
And then here's something from Pat some a little doodle, psychogenic, and his ADC. So yeah, we've already got the beginnings of a nice fertile ground for silicon doodle experimentation. And then the other side of things is actually generating the art with the chip. So the one thing that I liked about Uri's oscillating bones is that looks cool, but it also produces like a waveform when you measure it. So one of the other things you're looking at is this shader idea with the VGA playground. Sylvan's just asking, will they remove top metal too? Only top metal 1? That's a great question. And that's maybe something that we need to talk to Texplained and Sylvan and you, Bleeptrack, about so that we can get us all together. Because I think probably the reason Sylvan's asking is because the layer that we use for art might be different or might be more layers down. So it might be more difficult to... Getting the intermediate layers is harder. So it's like asking Texplained to do harder work for us. So we'll see what we can do.
I see.
So yes.
Yeah, but the decapping pictures you showed so far were really... I was really blown away by the detail of the photos. I didn't imagine you could make images still so close up on such tiny details.
Yeah, and these are the ones with the optical microscope. And I don't know if you've seen, but we've also got like these are the ones with the scanning electron microscope. Yeah. So they're the other great thing about the scanning electron microscope is you get so like a much bigger depth of field, so stuff looks like way crisper. Yeah.
Nice.
Yeah. So anyway, let's transition to the idea about generating the art inside the chip and then sending it out over VGA. Tell us about VGA Playground.
So I hope so, because I'm very new to this. So really,
is this your first time with Verilog?
If I'm wrong. Oh, this is my very first time with Verilog. This is why I had to prepare for this stream, because first I thought that we could do a little live code jam session, and I was like, oh, I don't think I'm grasping Verilog in its entirety already enough to do this live properly. Yeah, if you want, you can also activate the screen sharing for me, and we can have a tiny look at what's it looking like in the end. So maybe just make a new tab for this. So when people want to play around with the VGA Playground, they will end up something like this. So there's a little demo texture coded texture already running. And you can hop through a few examples. They're also really nice and cool. One is going very crazy with noise. One here has a very DVD-like feel, I'd call it.
Yeah.
And there's even more, like they're all very, very fun to look at and see how they were coded. And in the end, I think
that was Ray's demo scene in Trent. That's a great one.
Yeah.
Yeah, a complicated place to start, probably.
Really cool. Yeah, the drop effect is really looking good.
Yeah.
And I think, like, for me, oh man, that's so cool. I think for me, like already coding like regular shaders is kind of complicated, but coding shadery stuff in Verilog makes it like it really doubles the complexness for my brain. And what you can also do, what I have not tried, but I think should work very well with the Playground, is that you have also inputs. So you can have like virtual pins you can use, or use audio or gamepad inputs to like control what's going on the screen. So you can also, in the end, more or less write your own little games or audio reactive things. So that's really, really cool. And what I came up with is this little fun thing here. And at first I was looking for I'm not sure if you know this, like if you have like the typical old school demo scene entries, you have this tunnel effect that a lot of people are using. And I was thinking like, I want to recreate a tunnel effect, but I think Verilog's not giving properly sign functions, or maybe it's a bit more complicated to get at sign functions, or I didn't really find them. I'm not exactly sure, but I ended up with a little reduced tunnel effect, which is this fun prism thing.
It's very impressive for your first Verilog designs. Yeah. And by the way, there is no sign.
There is no sign,
in
right?
Verilog.
Okay,
you have to make your own.
Okay, good. Then at least I didn't completely fail in researching how I can access a sign function.
Yeah.
It's really hard because usually I rely so much on sign functions to make cool animation like stuff.
I think what people normally do is they work out how high resolution they want the answer to be, and then they pre-compute a lookup table. Yeah, exactly. Yeah.
Makes sense. Okay, next time I'm gonna go with the lookup table.
Yeah.
But so yeah, just in case people are curious what's going on in the code, we are defining a center and measuring the distance to the center like this. And then we can define colors depending on the distance, and adding a counter makes it animated basically. So if I would go and remove the counter variable, then it just it stays still. So that's the fun and easy way to animate stuff, is to just add the counter so it moves in some way. And the other thing is the background. So I ended up more or less XORing weird values together to get a funky
it looks cool.
Crossy shape background. And if people want to play around with that, you could just like, if you swap bits here, which bits you want to have, you get very different backgrounds. Like, it's very fun to just type different numbers in here.
You could potentially like connect that up to the inputs, so that when you get the design back, you can change the inputs and change what the backgrounds do.
That is such a good idea. I didn't think of that. Definitely. Yeah. How would I? Is this a quick thing to do? Because I'm not.
Yeah, you can. You've got the signals in there, like UI_in.
Yes.
So you can copy that and then say which bit of that you want, like bit 0, bit 1, bit 2, or a range.
But I would. If I want to use the wire to select which bit I'm XORing, that's not that easy, right?
You might need to create like some intermediary selector.
Yeah, but then I would just more go like this, maybe.
Yeah, and you could do like 1 down to 0, and then on the top right-hand side there, you should be able to change those. Yeah. It'll be 0 and 1 that will be doing the difference there.
Oh, yeah.
Yeah.
Ooh, is it doing a difference? A tiny difference, maybe?
Yeah. Yeah, it does look like it's making a difference. Play around with that and.
Oh yeah, that's what I'm gonna try next time. I go back to my other version, and we have more fun in the background for now. And the last thing that's basically happening is just I need to decide if I want to draw the background or the diamond. And so that's this XOR. That's this if else here basically. And then I just draw it, and if there's nothing selected, then it's just black background. Yeah, so that's
it's great. You can fit that all in just like 30 lines of Verilog, but still get a really cool looking output going on. So I was actually, I suggested we were going to do this the other way around, wasn't I? I was going to say, let's submit this to the IHP shuttle, and then while we're waiting for the GitHub Actions to run, we can talk more about Silicon Doodles. But let's try and submit this to the IHP shuttle anyway.
Okay, so maybe you need to help me a bit, but I guess I'm just downloading the zip, so I get the Verilog files.
Yeah.
And then I think, is this the current correct template, right? I would go with the Verilog template.
Just go to the Tiny Tape Out homepage.
Here we go.
And then scroll down to the submitting your design section. Oh, there you go. Get started. Scroll up a bit.
This one, I guess.
No, hold on a minute. Could be linked from the homepage. Yeah, submission template. Scroll down to the Verilog submission template.
Oh, okay. Here we go. Yes.
Just to make sure you're on the right one.
Yeah, that's it.
Oh, yeah, you were. Okay,
okay. Great.
Then you need to click that Use this template button.
Oh, even better. Okay.
That's it, yeah.
In
Create
a
a
new
new
repository.
Yeah.
And we call it Prism. Now we call it maybe Tiny Tape Out Prism. So okay.
Yeah. What's in the zip file that you get from VGA Playground?
Oh,
Whoa!
Neat. That did not work at all.
Just, I would guess,
okay,
I would reload that, see if it created it anyway.
All right. Yeah, maybe try again. Or it did. Yeah, it's already taken then, but then the repository is there, I guess. Nope, not where I wanted to go. Oops. My repositories. And here we go. And yeah, in the file I downloaded is 1 second. I think there's 2 files. Oh no, there's a source folder and an info YAML.
Okay. Yeah. So you want to take what's in the source folder and put that in your source here.
Yep. Does actually GitHub have a nice upload? Otherwise, I'm gonna clone it.
I think if you click on this, you can create a new file. Yeah, you probably want to do it inside the source directory though. You need to open the source directory first and then upload them into that one. So now you can add file with the top right hand corner.
Neat. I barely. Oops, nope. Upload file.
That's it. Upload files. Yeah.
Choose. So okay. Web. 1 sec. Need to extract that first. So trying not to dox my weird download folder.
I'll just remove your screen for a second. Something I've learned from from doing the live streaming is like, make sure that everything is hidden. Like if I'm going to open something in Google Drive or whatever, like open it on another tab and then drag it across onto the main window. Yeah, I've even had to like go back into YouTube and sometimes and blur things.
Oh yeah, and edit it out. Yeah. Oh no. All right, we have like the project, and I think that's more like a wrapper file, I guess, right?
Yeah. So the basically the thing that generates the VGA sync signals. Is like a pair of timers that create the pulses in the right times and places. Can you show the info.yaml that you got? That
I got from the sure thing. Looks like this. Yeah, maybe do it a bit bigger.
Yeah, I see. Okay, so you can see it's that's interesting. It doesn't list in the source files the HSync generator, but one thing it does give you is in the pinout the name of all the outputs. So now that we've uploaded your source file, we need to edit your info.yaml files on the in here. Actually, the other thing we're going to do is enable the GitHub action. So if you go to the settings on this repository.
Oh, yeah.
Have you done this before?
I have it, but that was,
It's
I
in,
think, a few
in
months
action.
ago.
Yeah.
In actions.
No, it's on It's on pages. Yeah, that's it. Pages. Bit further down.
Yes, you go.
And you have to say deploy from a GitHub action instead of deploy from a branch. That's it, the top one.
Yes.
Yeah. Okay, now we can go back to the editing the info.yaml. Okay, so you want to edit this with the pen tool, I think?
Yep. I think the main thing to do is give it a
from the top
unique
as well,
name,
because we
I
can't
guess.
leave any of these blank. So that can be Prism again.
All right.
And if you put your Discord handle in, then when you submit the design, it's going to name drop you on the channel.
Is it common to do it like with an ad or just without?
No, just without. Yeah.
Description.
Let's copy the clock hertz from the
file, yeah.
That was downloaded. So that's good when we get the chip back and you enable the design with the bring up tool, the commander, it will automatically set the clock to whatever that is. Okay, so then in your top module, that's going to be whatever it was. Can you load the what was the file that you uploaded to GitHub, the Verilog file? Can you share that?
The project one, yeah.
Yeah.
Sure, that's this.
Okay,
one.
so we probably need to change it because
it also says
TTUM VGA example. We need to probably change that to TTUM Bleeptrack Prism.
Then I also change it here for now, I guess.
Yeah. We'll change it in both places in the GitHub Actions.
Prism. All right. Another thing I need to change in here. I don't think so.
The source files, yeah. So you've got to list all the files that it's needed. So one is the.
And there's also
the HSync generator, the sync generator. That's it. Yeah. And the actual Verilog file was called project.v, was it?
Yeah.
Okay.
That's fine. Order of the files doesn't matter, I guess, right?
No.
Cool. Okay. Good to go for here.
Copy the pin out as well.
Okay. This one.
Yeah. Just because it's nice to have that. Then this is yeah. And then if you did go back and you use those inputs, you could describe them. And then when we print the data sheet out or on the website, anyone trying your design will get like a little pin out that says toggle this one to change the background color, do this one to do that one, whatever. Okay, so I think you can save and commit this. Just before you do that, copy the name on line 14 you've given.
Oh yeah, good idea.
Because we need to now go back and edit the project.v.
The project.
Mm-hmm.
All right. So we are in source project.
Yeah, and we've got to change that.
Name this one. Whoops. I'm not in editing.
Easy to make that.
Okay.
Yeah, that's good. Now, if we're lucky and we haven't missed anything on this commit, no, there's going to be one more thing. I know what it is. It's going to fail on the documentation. So on the docs directory, there's a file in there. And again, this is used for the website. So you just got to edit.
And it wants to have a bit of.
It's got to not be the default, basically. So you can come back to it.
And we make a tiny edit. Yeah, we make a tiny edit for now.
Yeah. in both those places, and then you can say which is the name of the. I think it's Mole 99's Tiny VGA is the name of the VGA dongle that we're going to be using.
What's it called? Can you say again?
Mole 99.
More like more?
Mole, like a little animal.
Like Mole 99.
Tiny VGA.
Whoops, VGA.
Yeah, that's it, yeah.
Okay. That's good to know.
So in the external hardware, you can drop a link to that. That's it.
Oops.
Yeah.
All right. Okay. Give me one very tiny second. I need to let my cat in, otherwise he's gonna scratch up the door for the next 10 minutes.
Yeah.
And I'm back. All right. So, okay.
So now we've got to now got to wait on the actions. So they're all the actions are automatically running, and then we have to see if any of them fail.
Hopefully not.
With your script that you've done for the weaving for the silicon doodle, do you have any like little advanced stuff you're willing to share, or do we have to any like pictures of what you're hoping to see on the chip, or do we need to wait and bide our time?
Let me see if I have something here, but it's maybe not super interesting to look at. Can I open this? Yeah, I mean, it's like really not super interesting to look at, but this is one.
It's just like a straight line.
Yeah, no, not exactly. Yeah, but this is like the last output that I have saved for thinking of doing a weaving structure. And what I'm, to be honest, not exactly sure currently, because we have there's this art layer, and I can simulate a weaving structure. But if I was thinking it would be even more fun to have an actual weaving structure through multiple layers. But in the end, I'm not sure how much this will be visible or not when we would do a decapping on that.
Yeah, might be possible. Like if we block the fill, and you could even make it so it's like woven together, so that if you connect like the input to the output, it's actually a line or a resistor. Cool. Yeah. Okay, I'm going to on the private chat of the StreamYard, I'm going to send you a coupon to submit the design. Fingers crossed if the actions work.
I can also maybe this is the submission.
Yeah, we could get started here. Yeah, create a new project here.
Do a nicer email than this lame one, maybe. Select this, so then I can already sneak the repo URL in here.
Yeah.
All right.
I just saw that the test has failed because we
didn't
change not the test, the docs. If you click on the actions at the top there, the top tab, that's it.
Sorry.
Yeah.
But it's that's already the error one.
Docs has failed. And it's because we didn't change the how to test. That was left as the default. I should have remembered that.
I see. Okay. Yeah, I see. The tiny tape out tests are smarter than I thought.
No, it's just it's in the docs. It's in the docs. It's yeah, in there. You just got to change it. Instead of saying explain how to test your project, you need to like plug in the VGAP mod and turn it on. Sylvan says, we can't block fill on large area unless the artwork intrinsically meets the density requirements by itself. So that's an interesting. So if your weaving creates enough density that we can block the fill,
then it could work, yeah.
It would work. But you would probably need to bear that in mind as you're working on what the pattern should look like. So you've got these constraints to work within. All right.
Yeah, but that's interesting. I think having heavy constraints usually brings out the more interesting
creativity
out in the end. Yeah.
Do you know why the fill's there?
I can't properly explain it. I'd say
it's
physics, physical attributes.
When you sample a little section of the chip, the average density of every layer has to be within a minimum or maximum, so that the whole wafer is the correct average density. And the reason why that's important is when they grind down the wafers in between processes, if one part of the chip is like less dense than another, you can end up with the grinding not happening completely evenly.
I see.
Okay, did the previous GDS job finish?
I think.
Yes, it's worked, and now it just finished successfully, and now we've got the pre-check, the gate level test, and the viewer all running. Your design is using 20%. It seems like if you click on that, the GDS job that is still running, like 5 down from the top.
5 down from the top. Here we go. Yeah.
Yeah, it's still running, but part of it is already completed. So you can have a look at what the output of the tools are here. So if you scroll down a little bit, you see your utilization. So your design is using 20% of the space. That's it. The 3D viewer is working, so you can load the design. Actually, that reminds me of something.
Nice. Oh yes, lovely. Look at that. That's really cool. Man. Nice.
Let me just share my screen for a second. So this is done by one of the guys on my course. He was able. This is how the placer is working in animation, and by setting a keep out zone, you can route a design so that it forms a logo.
Okay.
So that's what it would look like on the top of the 3D viewer. So one of the things I was thinking is if we can get that easy to use for people, you could maybe create a prism shape and then get your design rooted into the same kind of shape that it's going to make the VGA screen.
That's really cool. That's really impressive. Awesome.
Okay, so
I think did we ever fail?
And all the tests seem like they're working. If you click back on the actions, where are we at there? Okay, the test is done. Docs is still failing, and now the GDS is failing. Oh no, that's for the Verilog template. That's not your.
Oh, that's why. I was confused. Where did yours go? I think maybe yeah, I'm an idiot. I accidentally closed it because I closed this video.
Yeah.
That's the problem. I'm sorry. Oh man, kitty. Do you need to go outside again? All right.
Kitty
Never.
is making noises.
Never start having a cat, I tell you.
Well, let's go through this process anyway, and then because we're like just running out of time here now.
Yeah.
So on the submission page, what happens? So you got the coupon there. You can apply it.
Yep. Is it fine to just?
Yeah, it's fine because after you've applied, it will be
now?
out of commission anyway.
Okay. I need to be quick now.
What, you're just going to tick that box without reading our loan requirements?
I think we're running out of time, right?
you need to click that apply button as well next to the coupon code.
Oh yes, that's true.
That's it. Cool. And then you just have to submit project.
All right.
That's an interesting thing to feed back to Uri, that the okay, great.
Yep.
So you've been assigned space, and now when you press that submit a new revision button, it will probably fail, but let's try it anyway. It's always fascinating to see people using the interface. Okay, yeah, failed because because it's failed, we're still waiting on the GDS. But then basically every time you change on the playground, you need to update that VGA file that you download.
Yep.
You can probably just copy and paste it from the VGA playground directly into the GitHub rather than downloading and uploading.
Yeah, sure.
And then you've got to come here and press that submit a new revision button so that the shuttle is updated with your design. So
the shuttle is not seeing if
it won't ever take. We never assume that the latest is what you want, because you might be experimenting, or you might just have broken it and you want to. So with this button, you have to come and press it every time you want to tell us, hey, I've updated my design, you need to update yours.
Yeah, that's good to know. Yeah, makes sense.
Cool.
So if we are at people using user interfaces, I have a tiny request for the VGA playground.
Oh yeah?
What would be super cool is if you could share your current state in a way. So I know this from other online editors that like the content here gets URL encoded in some way, so you can share the complete URL with the content. It would be even nicer.
Okay. Yeah, I can. I'll let
send it to other people.
Yeah. That's one for Uri to do. So thanks very much for joining today.
Thanks so much for guiding me through the submission process. I'm very excited. First submission. Nice.
First ASIC, excellent. And yeah, I'm really. I mean, it's going to be like a long running project, obviously, like many years long. But yeah, I'm super excited to be collaborating with an artist to like explore silicon art in more ways than just doodles. So thanks very much for your involvement.
Yeah, thanks so much for having me.
And thanks very much, everybody, for joining the stream. I hope you found it interesting, and see you next week when we'll have Leo Moser, who designed the VGA PMod, is going to be on to talk about his latest chip, which is quite a big one. It occupies the whole die area and is a combination of RISC-V processor and FPGA. So if you want to get like the insights into a pretty technical, deep project, then join us next week for an interview and a chat with Leo Moser. Thanks again, Sabine, and thanks for joining, everybody. Bye-bye.